Welcome to the final video of Group Demo 5 with me, Steven Simmerk, and my group mates Tonu and Lily Sheng. We first want to explain our methodology. What we do is we first filter the image input to only keep the lanes of the track we need. We then put that image through a pre-trained network which we modified to get a segmented image output. We use that image to individualize the lanes we need, from which we can calculate the lane radius and thus the steering angle.
This is our guiding logic, the controller, where we use the PID to determine the new acceleration and publish it. Then for our essential lateral controller, our lane segmentation images are fed into our curvature calculator, where we use some geometric and physics to find a new steering angle. If we couldn't detect any of the lanes, we'll maintain the original steering angle.
Here are results for our lane detection. As you can see here, when we're driving through a yellow parking lines area, our algorithm is not picking up the lines as actual lanes. We mentioned before that it was interfering with our lane detection algorithm. And now we're able to successfully filter out the yellow lines so that we only have white lanes as the actual lanes that we want to follow. In the next slide, we can see that when we are going through a straight course, we're able to follow and steer the straight course. And when we're entering the left loop, as well as exiting the left loop, it is also able to follow accordingly. It is also able to go back to the straight course and continue.
Now, let's see the final results of our lane following controller on two trials. Our deliberate use of 1 meter per second for the PID controller's desired speed is to synchronize the YOLO PV2's outputting rate with the car's movement. The car will safely finish the loop without rollover nor driving off the track due to our controller logic.
We wanted to implement a fully vision-based approach. However, with the complexity of the track given, we were forced to test a waypoint generation algorithm, which unfortunately we did not get fully working.
Throughout the project, we'll be measuring our steering angle accuracy to meet the initial metric that we set to ourselves at the beginning of the project, which is comfort. The yellow solid line here represents the optimal driving data generated by Lily, our safe driver, driving for a full lap, whereas the black solid line represents our controller's outputting steering angle during autonomous lane following. We could tell that they align for the most part, but still need work to smoothen the edges as illustrated from the purple dashed line.
We lastly want to thank all of you for the amazing job you did in helping and teaching us. We also want to cite our references we used to help write our code.